Hello, Trig class. We are going to talk about the practice test that goes with section 9.6, which is about vectors. And as we go through this practice test, I'll just remind you of the facts you need to solve whatever problem we come across. All right, so the first one, you're asked to calculate a number times a vector. So how do you do that? I'll just remind you, you just take the vector that you're given component-wise, and you multiply each component by that number. So that number distributes. So you get 4 times a minus 6. And the other one is 4 times 0. So the answer is minus 24 and 0. All right, the next one, you're asked to create a vector given 2 points. So let's call this point P, and we'll call the other point Q here. It says in the directions that we should take the first one to be the initial point, and the second one to be the terminal point. In general, to create a vector whose tail is at P, which makes it the initial point, and whose head is at Q, which we symbolize this way, tail at P, head at Q, what you do is you just take the x-coordinate of the head, subtract the x-coordinate of the tail, go on to the next component, take the y-coordinate of the head and subtract the y-coordinate of the tail. So that would be minus 5 minus 20. So that's this vector. In general, if you have a point P, which is x1, y1, and a point Q, which is the point x2, y2, then the point PQ, or I should say the vector PQ, which is the vector whose tail is at P and whose head is at Q, is just difference in the x-coordinates, head minus tail, difference in the y-coordinates, head minus tail. So that's how you do it in general. And remind you that to get the magnitude of a vector, let's suppose you had components u1 and u2. If those are your components of the vector, remember these 2 vertical bars on each side mean magnitude or length. The definition is you square each component, you sum that, and then you take the square root. Because in general, it's first component squared plus second component squared, square root. So in this case, that's 5 squared, which is 25, and 20 squared, which is 400. So you get the square root of 425. And if you wanted to factor out any perfect squares in there, you could take 25 and, let's see, 25 times, well, let's just do 425 divided by 25 on a calculator. If I do 425 divided by 25 on a calculator, that's 17. So if you take the square root of 25, that's 5. So you get 5 times the square root of 17. That's one way to write your answer. All right, next one. I'll remind you that if you want to find a unit vector that's in the same direction as the vector that you're given, unit vector just means it's a length 1. You just have to divide your vector by its own length. So you can create a vector of length 1 by dividing the original vector by the length of the vector. So we just talked about how to find the length of a vector. So you just take the components and square them. You add them together, and then you take the square root because that's the definition of the magnitude. In this case, that'd be the square root of 26. So a unit vector that points in the same direction as this given vector is that vector divided by its length. Or in other words, 5, negative 1 divided by the square root of 26, which would be the same thing as saying 5 divided by the square root of 26 minus 1 divided by the square root of 26. All right. It's easy to take a given vector and write it in terms of I and j, and I'll just show you how. I'll remind you of what I and j is as we do it. So you could take a vector and break it into its horizontal and vertical components. The first number is the horizontal component, so that goes only horizontal because the second coordinate is 0. And then this is only vertical because the first coordinate is 0. You could factor a 5 out of the first one and a negative 1 out of the second one. And the reason you do that is because these guys have their own names. The vector 1, 0, that's vector I. And the vector 0, 1, that's vector j. So the linear combination that's the same as the vector v is 5i minus 1j. That's the answer. Notice it's the same thing as the components themselves, and it will always be like that. So you can always make it just go right to the answer if you want. It's always going to be this number times I plus this number times j in terms of the linear combination of I and j that's the same as the vector. Okay, so let's just remember before I turn it over that I'm trying to find the magnitude and the angle of the following vector. Okay. So, all right. So they have, looks like they have this parenthesis in the wrong place. So, although it's written this way, there has to be a closing parenthesis. Well, let's see. I guess you can write it that way. I would distribute the 5 though. So what they mean is 5 cosine of 28 degrees I plus 5 sine of 28 degrees j. And then we know that that's the same thing as saying the components 5 cosine of 28 degrees and 5 sine 28 degrees. Okay, so all that's going to happen when I measure this and get the length of it, it's going to be 5, because cosine squared plus sine squared is 1. So I already know that before I do it because of that 5 out in front. But I'm going to show you that it works that way. So if you remember the length of a given vector, here's the vector we're working with. You're supposed to square and sum the components. So there's square and sum of the opponents. But there's a common factor of 5 on the inside of that square root. So you could factor that out on the inside and have 5 squared times cosine squared of 28 degrees plus sine squared of 28 degrees. But we know that cosine squared plus sine squared is 1, so that's the same as the square root of 5 squared times 1, which is the same as the square root of 25, and that's 5. Now, it does have to turn out that way because there's a 5 in front of this. Okay, and then for the angle has to turn out to be 28 degrees because you could decompose this vector into its horizontal and vertical component. This would be 28 degrees. This is your vector, but the length of the vector would have to be 5 because the I and j are unit vectors, and there's a 5 multiplying the whole thing, which is why we got 5 when we measured it. And if you broke down the components, this would be we'll name it V1 and V2. Cosine is adjacent, which would be V1, divided by hypotenuse, which is 5. So that makes your V1 equal to 5 cosine of 28 degrees. And the sine of 28 degrees would be opposite divided by hypotenuse, which would be 5. So your V2 would be 5 sine of 28 degrees. So the angle has to be 28 degrees just because it's of this form. All right, so let's keep going. And we will move on to number 5 in the next video.